Greetings and welcome to MBA 532. The title of this course is Artificial Intelligence in Business. I'm delighted to have you here. I have been teaching this course for several years now and look forward to teaching this one. Um, Students have liked this course primarily because this is a very important and changing topic that requires a lot of attention. Artificial intelligence, as we all know, is a fast evolving field. To teach this course, it's best not to use a textbook. This is because a textbook gets outdated very, very soon. And I thought a lot about this. And the best way that I have settled over the years to prepare for this course is by reviewing several books written by some of the leading edge practitioners of artificial intelligence and also educators, researchers, uh, uh, political leaders that are contemplating artificial intelligence legislation, for example, people who are planning to invest in artificial intelligence. All of them write books and share their experience. And you can learn a lot from that. That's what I have discovered over the years. So each year I invest in the latest books that have been published on this and then read that over the summer and over the entire year as the books get published and are appearing on Amazon. And then I distill that content that are particularly relevant for the materials that I cover in this course, and they go there. Okay, so I'll give you a preview of some of those books very, very quickly. It is available. Uh, some of it is available in this presentation, and I believe you have access to that later in the course syllabus as well. Now, in addition to that, I also draw upon some of the latest journal articles that are published about artificial intelligence. And so these are the leading industry sources that influence managerial thinking as well as MBA students all over the country and the world. Those sources are the Harvard Business Review, MIT Sloan Management Review, and MIT Technological Review. Um, so let's move on to some of the books that I have consulted. And this slide just summarizes what I already shared about my LinkedIn profile. So you have my LinkedIn profile again there if you want, and then you can make a decision whether you want to join or not, but I leave it up to you. So here are some of the books that I have consulted in developing these course materials, and they are absolute cutting edge materials. Okay. And here is additional books. So these books span over the last maybe 5-6 years, including the ones that are the latest ones that appeared on Amazon. In addition to that, as I mentioned, I also consult these journal articles that are published in leading business journals. So those are listed here and here. And so coming back to the content of this course, there are 8 modules, as you know. We'll start with module 1, which just provides you with a overview of the entire artificial intelligence landscape. That's very important because many people do not need any introduction to artificial intelligence, but they need to know the learning context for this course. So we will absolutely, at the end of this course, you will have completely obtained all the materials that will sharpen your knowledge in terms of what you want to accomplish out there with regard to artificial intelligence contributing to your career, for example. So you will become completely familiar with the landscape of AI, and particularly with regard to how to use the newly acquired knowledge in terms of business environment. Okay, so we will have coverage here for any aspect of artificial intelligence as it relates to business. We'll also review artificial intelligence history. We will look at what are the broad benefits and threats that this provides. We will look at success factors. We will look at AI's impact. and market size and growth rate. Okay. Module 2 is about defining and clarifying AI and related concepts. So let's see what we do here. I mean, we will review all the generally accepted popular definitions on this subject. We will look at notable quotes from AI leaders. We will look at the strengths and limitations of AI. We will explore machine learning in some depth. And we will provide a good understanding of what is a shared definition. There's no universally accepted shared definition, but there are popular definitions of artificial intelligence and machine learning. So we'll hone in on those. In the third module, we're going to talk about a lot of things on our minds right now. So it's not like we have not heard of the term artificial intelligence before this course. We have heard it a long time ago. Okay, this has been around for a long time, as the AI history review will demonstrate. So the fundamental question on everybody's mind is, why now? Why has suddenly artificial intelligence acquired such a major prominence? This is primarily because artificial intelligence really represents a bundle of technologies. So it's not just machine learning. It is computer vision. It's natural language processing. It is a host of other technologies like cloud computing, ambient computing, everything. And now we have now we have large language models. Now we have GPT services that are available from multiple providers. And more important than that, we have multimodal capabilities on some of these GPT and large language model products. So it's constantly new and new technologies are getting added to this domain. And what this module 3 does is provide you a very, very quick overview of many, many complex technologies and provides you like a bird's eye view of what's happening at the macro level in terms of how these technologies are interacting with each other and bringing new capabilities to artificial intelligence. So it's a very exciting domain that we will look at. In module 4, it's a very important thing. We always know that humans would like to be on top of their game. They don't want to surrender control to artificial intelligence. So we will broadly compare here what are the unique AI abilities that AI brings to the table and how does it compare with human abilities? And what is the potential that exists out there for human-machine collaboration in the future? In module 5, we are going to talk about AI's impact on jobs, work, humans, productivity, something which is at the top of the minds of many, many people right now. So we'll kind of explore this in some depth. We will look at a concept called anthropomorphism. We will look at potential for job losses, some of the implications in terms of retraining, acquisition of new skill sets, reskilling and lifelong learning for people who have been working a long time in the same place. There are so many issues here that we would have to deal with. Module 6 looks at artificial intelligence impact assessment, other key dimensions and multiple perspectives. And then we will wrap this up with module 7 and 8. Module 7 talks about generative AI, responsible AI, and explainable AI. Module 8 talks about AI platforms, AI ethics, and AI regulation. So with that, we will move on to some administrative aspects of this course. I wanted to share the grading policy for this course. It's very important that you complete the readings each week as expected, following the course of each module. Participate in the discussions that will be announced, and complete the summative module assessments and the summative course assessments, and a cumulative grade that would reflect the sum of all these course components would reflect your course grade, which will follow this distribution. And this is as per Illinois Tech policy. So that's for your information. Um, Again, I hope you will enjoy this course. I'm very excited to teach this course, and there's a lot of content we have. So look forward to that. Thank you. Greetings and welcome. My name is Siva K. Balasubramanian. I'm the Harold L. Stewart Endowed Chair in Business, Associate Dean and Professor of Marketing at the Stewart School of Business, Illinois Tech. So I have been at Illinois Tech for 16 years, teaching here. I have a PhD in marketing from University at Buffalo and several years of managerial experience in the industry in a multinational corporation. Um, I wanted to share something with you with regard to my LinkedIn profile. This is a profile that I use often to comment about latest developments in artificial intelligence as reported in national media like the Wall Street Journal, New York Times, and so on. And so, what I do is when I get an interesting media piece on artificial intelligence, I comment on that. And all those comments become a part of my LinkedIn profile. And in the past courses that I've taught on artificial intelligence, my students have liked to follow me and join my network so that they can actually be exposed to some of those comments and other general commentary I have about artificial intelligence. So if you wish to do that, I have also provided you here my LinkedIn profile. If this you really want more details about this, you could always go to my Illinois Tech website. My LinkedIn contact info is right there, as well as my website, so you can explore that. An additional benefit of that, of joining this, is that I'm also a member of several groups on LinkedIn that are related to artificial intelligence, machine learning, and so on, many related topics. So, what happens is that is a good way for me to keep in touch with some of the more recent developments in not just artificial intelligence, but other related areas as well. And so if you join my network, you will also be exposed to that content, which I think is really cutting edge and very useful. Greetings. Let me provide you with a quick introduction to Module 1. In this module, we'll look at the complicated history of artificial intelligence as a concept, which emerged around the middle of the 1950s through 1960s, and a little bit earlier than that, maybe 43 onwards in some cases, but when the rudimentary concepts were taking root. But we'll get a good flavor for the entire history until the current day for how these developments unfolded. We will also look at various types of AI so that we become knowledgeable about this space in terms of interacting with other knowledgeable people about AI. AI's impact metrics. So here we will look at um, how much of a contribution AI is supposed to make to the economy. What kind of market size are we talking about? What is the growth rate of this market? And we will also look at what are the key technology catalysts for AI. Now, in terms of all these metrics, the market size and growth metrics, we'll get the latest data from a lot of international agencies, consulting companies like McKinsey and Deloitte, and also US government sources like US Bureau of Labor Statistics and many other um, governmental sources, including the Federal Reserve. So, lots of agencies are tracking AI progress because this become a very critical aspect now with a lot of governmental interest in AI endeavors. Greetings and welcome to MBA 532 AI in Business course. This is Module 1 and Lesson 1. Lesson 1 has 4 parts. We'll start with the first one, titled AI Overview Landscape. In this lesson, we are first going to focus on what AI represents or means. It's a definition of this important concept. AI represents a concerted effort to understand the complexity of the human experience in terms of information processes and potential ways to automate these processes to improve desirable outcomes for business. So the focus is always on business operations. AI deals not only with how to represent and use complex and incomplete information that might be available in business databases in a more logical way, but AI also deals with questions on how to see, because AI primarily relies on computers. So here when we say see, we mean computer vision. When we say move, we are talking about mobility or robotics. When we say communicate, we are talking about natural language processing, speech. We are also talking about different modalities like print, like audio, like video, images, and finally, the most important component, which is learning, the importance of learn, which includes memory, reasoning, and classification. Memory just focuses on retention of information, reasoning focuses on decision making, and classification rests mostly on the outcomes of actually using business data to render it more meaningful for business decisions. Module 1, Lesson 1B. Um, we will, in Lesson 1B and 1C, we will focus on a review of AI history. This is part 1 of that review. The review of AI history begins in 1950. So much of the action in AI has been less than a handful of decades, but so much has been accomplished within that short time. This review also shows many ups and downs in the history of AI in terms of progress, in terms of government support and funding, which has not been consistent, unfortunately. It also will highlight the role of serendipity and cross fertilization of ideas in scientific and technology progress. So, something that was seemingly unimportant, that was a scientific discovery in one field, actually becomes pivotal and instrumental in major progress in AI years later. And because of this significant leaps in progress, AI has made considerable strides today. As I said before, everything started in 1950 with Shannon's publication um, called Programming Computer for Playing Chess. This was a published article on developing a chess playing computer program, the first one. In the same year, Alan Turing published Computing Machinery and Intelligence, which was the first attempt to launch an imitation game, which will later turn into what is now known as the Turing test. We'll discuss the Turing test later in the course. In 1955,
the term artificial intelligence was first coined in a proposal for a conference on artificial intelligence that was submitted by John McCarthy from Dartmouth, and it assembled for the first time all the leading world scholars in this nascent field. And this workshop went on to become so influential that it is often cited as the benchmark or the first beginnings of the concept of artificial intelligence. In 1958, Frank Rosenblatt's invention of perceptron marked a breakthrough in machine learning, allowing algorithms to learn from data. For the first time, data, which represents mostly numerical data, was used for machines to learn from data and then become available for business decision making potentially. In 1959, Arthur Samuel coined the term machine learning, and it reports on programming a computer so that it'll learn to play a better game of checkers than can be played by a person who wrote the program. In other words, better than a human being's performance on the game. 1965, Dreyfus publishes Alchemy and AI, arguing that the mind is not like a computer and that there are limits beyond which AI would not progress. Now, this has been like a yin and yang type of relationship in scientific discovery, when every time AI advances in terms of its abilities, there will be a bunch of scientists that also say the opposite view, that there are significant limitations going forward. This cannot be counted on to happen forever. In 1965, Good wrote specializations concerning the first ultra intelligent machine, where the first ultra intelligent machine is the last invention that man needed to ever make, provided that the machine is docile enough to tell us how to keep it under control. In other words, the assumption here is that after this major invention, every other discovery would be machine made, not man made. In 1970s through 2000s, the entire discipline of AI went through AI winters, and this has been a phenomena where AI lost much of the progress trajectory, primarily for lack of funding. It also followed disappointing outcomes. There were lack of incentives to investigate AI. In the early 80s, the introduction of the back propagation algorithm revolutionized the training of multi layered neural networks, enabling the development of more complex computer architectures and the emergence of deep learning. Module 1, Lesson 1C. This is the part 2 of review of AI history. So, beginning with 2009, significant milestones happened. The first important step happened in a paper co-authored by Reina, Madhavan, and Ng, large-scale, deep unsupervised learning using graphics processors. It argued that modern graphics processors far surpass the computational capabilities of multi-core CPUs, and that GPUs have the potential to revolutionize the applicability of deep unsupervised learning methods. Now, this is a pivotal finding because much of AI progress since 2009 has been based on the fact that GPUs offer a much superior architecture for artificial intelligence computations than CPUs. In 2009, Google started developing in secret a driverless car. In 2014, this car passed the test for um, self-driving test in a U.S. state, Nevada. In 2022, and this is a very important step, OpenAI introduced ChatGPT and reached 100 million users within 2 months. This was a phenomenal accomplishment that has never ever been replicated by any previous product introduction in human history. The speed with which people embrace this underscores the potential that exists for developing AI. What are the implications and follow up developments from these reviews of AI history? Except for two AI winters, AI has made steady progress by integrating several technology capabilities together following the introduction of GPUs, NPUs, IPUs, and DPUs. We will discuss these terms a little later in Module 3. Much excitement has accompanied ChatGPT and large language models, called LLMs, which arrived soon after OpenAI's introduction of ChatGPT. On the hardware side, NVIDIA's various chips, starting with H100, H200, B200, GB200, they have become widely popular for deploying generative AI applications to business problems. More recently, NVIDIA introduced Blackwell AI chips and data centers and the GeForce RTX series for consumer grade PCs. What we have here is a significant escalation in the quality of CPUs and on other very sophisticated AI based architectures, starting with GPUs, NPUs, and now the latest one is DPUs for data processing units. Welcome to Lesson 1D. Title is No AI Types, Avoid AI Myths. Both are important. We'll start with the AI types. In my view, there are basically three things to understand here as basic concepts. The first one is narrow AI. Narrow AI is a usually very structured task with a limited domain knowledge, and you are only focusing on one task here, one limited task. This could be something like a simple voice command to a voice assistant that is primarily powered by AI, or it could be a simple task, um, uh, that involves a voice command, and usually it is done as well as a human can, but usually more efficiently. AI systems that are limited to one function or operation can be characterized as narrow AI. Perfect examples of narrow AI are voice assistants like Amazon's Alexa. The second category is broad AI. What does this represent? Obviously, a much higher and more complex type of tasks, usually involving decision making at various steps. A great example of this is a self driving car or an autonomous vehicle, as it's often referred to. It accomplishes very complex tasks simultaneously. Examples include not only navigating movement of the automobile, but also keeping track visually of what is happening around the vehicle, keeping track of the speed of the vehicle, keeping track of the availability and responsiveness of the braking mechanisms, keeping track of the surrounding vehicles around the automobile, keeping track of potential pedestrians that might be crossing ahead of it, keeping track of climate control within the car, that is the autonomous vehicle, and keeping track of the entertainment system within the vehicle, for example. The visual capabilities are usually handled by LiDAR, and these are very complex instruments that provide a continuous feed of data on the visual environment surrounding the vehicle. Much of the progress on narrow AI and broad AI is currently implemented through machine learning that employs algorithms or models to make predictions. The next concept you should know is artificial general intelligence, or AGI. This represents an AI system that accomplishes tasks that surpasses a human's intelligence. And then there is another level, next level concept called superintelligence that represents intelligence that far exceeds the sum of the intelligence of all human beings. So this surpasses the intelligence of mankind. When we focus on AGI myths, we should understand that there are only facts and real worries. Here are some myths that have become very popular. The first one is superintelligence by 2100 is inevitable, or superintelligence by 2100 is impossible. Both are incorrect. The correct answer is we do not know when superintelligence will ever happen or when it will happen. It's possible it may never happen. We simply do not know. There's another myth. Only people who are afraid of technology, they worry about AI. That's not true. AI researchers who are carrying on very sophisticated studies on AI, they are constantly worrying about AI's future. They are extremely concerned about some of the really negative outcomes that can happen from AI. The third myth is AI may turn evil. AI may become conscious. This is another term for sentience. AI may become sentient, for example. This is a real worry. AI may become competent, and the real worry stems from the fact that the goals of AI may not be aligned with the goals of human beings. The fourth myth is that robots are a concern. It is important to remember that misaligned intelligence in AGI is the main concern. When AGI happens, its values and goals must be aligned with human values. As long as that happens, AGI is nothing to worry about. But if AGI's goals are different from human beings, that's a real concern. The fifth myth is AI cannot control human beings. We do not know this. Intelligence enables control. Humans can gain control by being smarter about AI. You do not want AI to become smarter than human beings and start controlling human beings. The sixth myth is machines cannot have goals. This is not true. Even a heat seeking missile has a goal. Machines can indeed have goals. The seventh myth is that AGI is just years away. The real worry is AGI may be decades away, we just don't know. But it is our responsibility, if it happens, to be safe, always safe.
Now, there are a lot of myths that have evolved over the years that I thought I'll just take a moment to review here. Super intelligence will happen by 2100. There's no magic number or year when this is going to happen. So you can't just say super intelligence super intelligence, by the way, is another term for AGI, artificial general intelligence. Um, and what artificial general intelligence represents is a point where artificial intelligence has essentially take over not just your life, everyone's life. And you're trusting artificial intelligence implicitly. Not only you are trusting, your government is trusting, everybody else is trusting. And so you think that as a public resource that you can trust, that you are entrusting everything, and in the process, you are freed of worries about everyday routine and a host of other things that you normally would do otherwise. Now, the simple fact is it may happen in decades, centuries, or never. We simply do not know. And there's a myth only, certain people worry about AI. That's not true. I don't know, many of us want to be classified using that label, but many top AI researchers are extremely concerned about that. The third myth is that AI may turn evil. AI may become conscious or sentient. This is a real worry. AI may become competent. The particular worry is that the goals of artificial intelligence systems, when the transition to AGI happens, or if the transition to AGI happens, if those sets of goals for the AI system is not aligned with the human goals, then you can expect in short order a lot of disruption, a lot of damage, in short, calamity. So we hope that never happens. The fourth concern is robots are my main concerns, not AI. I mean, robots, I think robots are AI. Okay, I think misaligned goals of intelligence in AGI is a much, much bigger concern than worrying about any specific aspect of artificial intelligence like robotics. Fifth concern, AI can't control humans. Well, the fact is, intelligence enables control. Humans can gain control by getting smarter. Maybe one way to do that is to think of ways to control AGI before it happens, so you're prepared for it. Okay, certainly you're not going to be prepared to stop AGI after AGI has taken over your lives and it is far superior on intelligence than most human beings. Then you have no hope. I think now is the time when you have prepared for it, and a lot of governments are aware of it. They are allocating funds for that type of research. Fortunately, we are now living in an era of abundance when it comes to funding with regard to anything that relates to artificial intelligence. And this is true not just of the US government, but governments all over the world. It's also true of companies that do not want to be left behind their competitors in terms of investment decisions in artificial intelligence products at this time. Okay, sixth myth, machines can't have goals. This is not true. All machines can have goals. Seventh concern or myth, artificial general intelligence is years away or just years away, maybe around the corner. AGI may be decades away, but it may take that long to become safe. So again, this response here reinforces the value of preparing for AGI in a manner that you at least have some preventive measures in place in case nobody likes it, in case a calamity hits, in case something untoward happens. Okay, at this point, it's very important for us to understand what are we talking about? What grounds us here? How big is this market? Is it even worth talking about? Is it even worth spending too much money right now on artificial general intelligence, either at the government level or at the level of private companies or public companies? Good question. Okay. And this comes from Statista. It's a worldwide renowned source of business intelligence. It's trusted extremely widely. It is well regarded. And so Statista came up with this estimate in 2021 with a forecast for 2030. It's promised to renew this forecast sometime later, every few years. So we will wait for the next update here. But till then, we have this information from Statista. So what you see here is up to 1.7 trillion by 2030. So it's a very, as you can see from this graph, it's an exponential graph. So the growth is exponential here. And this is a worldwide market size estimate computed in 2021. And remember, ChatGPT was introduced in November of 2022. And I'm sure it must have contributed a significant expansion to the estimates or forecasts in this graph. So we look forward to this update whenever that happens. Within the market for artificial intelligence, a subset of that is devoted to generative artificial intelligence, which captures all the market represented for large language models. Now, this includes ChatGPT, Microsoft product, Google product, a host of other competitors, as I previously described. So what is the market for generative AI? And this came from 2022, right after ChatGPT was introduced. And so what do we have here? They are expecting a cumulative average growth rate of 42% per year. And look at this, it's even more exponential than what you saw in the previous graph. So generative AI has suddenly become the component within AI that is at the driver's seat right now. Even companies that have nothing to do with retail consumers, let's say business to business industries, they are vested now and excited about ChatGPT and what you can do with ChatGPT, even if you are primarily without any contact with the consumer sector. So every sector of business is touched by generative AI, as we will see later in this course. Let's further break down, as we did in the previous couple slides, from the total worldwide market to generative AI market. Now a breakdown of the generative AI market. So what you see here is independent estimates by different components of the generative AI market that Bloomberg put together in 2022. Okay, this estimate comes from another source, and that is marketsandmarkets.com, again, a very reputed source. So what you see here, if you aggregate the estimates worldwide, okay, it ranges somewhere between 1.3 trillion to 1.7 trillion between now and 2030 or 2032, depending on the source. So, it's a huge market. Everyone is excited by that. And relative to the size of 1.3 trillion, you see, we are closest to, I think, the 2023 market. So you can see it is going to jump almost tenfold in the next 5 to 8 years. It's a huge, huge increase annually. Okay, this my hunch at this point, because all these forecasts are somewhat dated by about 1 year to 3 years. I would expect these forecasts, if you were to reforecast now with the current data, it would be at least 30% higher. So that's just a personal estimate. Okay, moving on. So you have a good understanding now of the exciting market size as well as the compounded or cumulative annual growth rate in these markets. Okay, so let's take the markets and markets forecast and look at both the short-term implications as well as the medium-term implications, because the long-term implications are too difficult to predict. In the short-term implications of the last forecast that we just saw is that all the business organizations have an imperative to fine-tune and optimize their large language model products for various applications. Okay, we will delve into what we mean by fine-tuning and optimization. Primarily, what happens is something called retrieval augmented generation, RAG. You'll frequently encounter RAG now, both in the media as well as in some of the modules in this course. Now, what is the role of RAG? We'll go into that later, but the short version here, what we mean by fine tuning and optimization, is that you're using RAG, and that's because many of the large language models that come to you as a business customer has been pre-trained on a different database than what you use in your business, right? So now to acculturate that model to your own circumstance and environment, you will have to go through this RAG routine, retrieval augmented generation, where what you're trying to do is to embed into the database your own data so that the chat GPT can learn that and embed that in its computations so that the recommendations it makes would be more, I guess, tailored for your particular firm or context. Okay. And then the second thing they have to do is to integrate text-based generative AI with other modalities such as images and videos. When ChatGPT was first introduced, you had to type in everything, right? And it will only take inputs in the form of text. Now, of course, it's expanded, right? Now you can actually speak to a ChatGPT. You can also type in, but now it's expanded from print to voice. And now we have integration beyond print and voice. Now you have videos thrown in there, you've got audio files thrown in there, and then you've got, images. So you got all these things that are truly representing a product that's evolved from one single way of communicating with ChatGPT to a multimodal framework. Okay, when you do that, what is the benefit for a large language model like ChatGPT? Now we can incorporate more data in its training, right? Because previously it was only looking at domains or databases that were available in a print format. Now it can look at audio files, now it can look at video files, now we can look at images. So the entire context of learning has become enriched, and also the user experience has become enriched. So, and this is only going to set the market growth rate on fire. Okay, all these forecasts that I just shared with you may be underestimating the true potential of the AI market. As I previously said, maybe at least 30% higher now. All right, medium term implications for artificial intelligence market forecast. Since we're talking about generative AI models a lot, I would just say I agree with their implication from markets and markets.com that generative AI models will become more domain specialized, particularly with retrieval augmented generation, which I just described to you. And then users acquire fine-grained control over the style and tone of communications and the ChatGPT or any other LLM response. Generative AI models seamlessly will integrate with existing software within a business and platforms that businesses subscribe to across several industry verticals. These developments increase generative AI's capability to adapt to industry-specific needs and to a diverse large language model market. So very interesting and exciting stuff.
Module 1, Lesson 2B. In this lesson, we are going to focus on the size and the growth rate of the AI global market for generative AI. What is generative AI? It is a subset of the overall AI market. Generative AI represents artificial intelligence capable of creating original content such as text, images, audio, video, or even software code in response to prompts from a user. It leverages advanced deep learning models, such as transformers, to identify patterns in vast data sets and generate coherent, contextually relevant outputs. So, what we have here is artificial intelligence generating new content as opposed to regurgitating old content, which was typical of AI responses before the onset of generative AI techniques. We are going to be reviewing the size of the global generative AI market and the growth rate from multiple sources. First up is Mordor Intelligence forecasts for the market for generative AI globally. Now, this is expected to go up from the $20 billion range, so something closer to the $100 billion range by the year 2030. So it's roughly 5 times increase in 5 years. Moving on to the next source here, Grandview Research. This forecast is also very similar to the previous one, at least in terms of the order of magnitude. And again, this shows generative AI going up from roughly the $20 billion range in 2025 to 108 or $109 billion in 2030. So roughly around, instead of 100 billion, this is closer to 109 billion. So in the same ballpark, if you will. Next up is a forecast from S&P Global, and this has a forecast until the year 2029, so not exactly comparable to 2030 forecast, but this forecast is in the $80 billion range, 85 roughly, if you will. So all these forecasts, because they come from different sources, they probably differ based on the definition of the generative AI market and the technologies and the forecasted capabilities and the rate of growth of these technologies over the next years until 2030. What are the medium term generative AI substantive forecasts? What implications do they carry for us? The first source of information that we are going to evaluate is from marketsandmarkets.com. Here are the medium-term implications of the AI market forecast that we saw for the years 2026 to 2028. For this 3 year period, generative AI models are expected to become domain specialized with extensive use of RAG, which stands for Retrieval Augmented Generation. We will talk a lot about retrieval augmented generation in a future module. It's also forecast that users acquire fine grained control over style and tone of AI outputs. Furthermore, generative AI models will seamlessly integrate with existing software and platforms across industry verticals, which means that there'll be extensive use of AI in a number of everyday practical user applications. These developments will increase generative AI's capacity and capability to adapt to industry specific needs and to a diverse large language model market.
All right. So let's take a step back here and just look at, okay, what we have discussed so far in module one, and then evaluate each of those dimensions along the spectrum of the scales provided in red. Okay, so what you see here, in terms of the outcomes from artificial intelligence that is expected, do you expect to injure us? Will we survive through it? Or will we actually thrive and grow? Okay, for the various artificial intelligence types that we discussed, where do you think we are right now? Okay, for magnitude of improvement in business outcomes, do you think artificial intelligence will not change anything, or will probably grow at a linear rate, or will grow at an exponential rate? For all the reasons that I've described so far in module one, I would say the bets are more toward exponential growth. Ethical impact of AI. Now, ethics of AI is a very rich topic. It's a growing topic in importance. Governments are paying a lot of attention. A lot of impending regulations of artificial intelligence pay a lot of attention to ethics from an artificial intelligence perspective. So, how do we evaluate ethical impact? Is it negative? Is it neutral? Is it positive at this point? Who will eventually be in control because of AI? Is it machines or is it humans? Speed of progress on AI, should this be frozen by governments or some type of mandate? Should it be slowed by, again, with some type of mandate? Or should governments and businesses actively encourage it so that the growth is rapid? Where is the progress most noticeable? Is it on generative AI? Is it on responsible AI? Is it on explainable AI? Where can artificial intelligence help humans the most? Is it on repetitive, boring tasks that can eliminate easily? Is it because artificial intelligence has an infinite longevity? Okay, so humans can go on vacation and outsource everything to artificial intelligence. And that's very cool, you know. Even if you're talking about a huge reduction in the work week, I'm sure everybody will welcome that. And what is the primary reason where any future changes in work week might happen? It's all artificial intelligence driven, period. There's nothing else that is such a large force working on society that would make that happen. And what is the relationship of AI capabilities and human capabilities? We are going to devote an entire module on that. Are we saying there is no overlap between these capabilities? There is overlap. Or are we prepared to say that artificial intelligence actually elevates or augments human capabilities? What is a likely trajectory of how humans will perceive AI in future? Is it adversarial? Is it neutral? Is it friendly? A lot of these things are happening. There's lots of moving pieces now. Maybe there are no definitive answers at this point, but we all will have some opinion on this, each of these dimensions. And that's the point of this. Okay, to paraphrase what I said earlier when I reviewed I.J. Good from his writings in 1965, if AI continues to maintain its rate of progress right now, it may represent the last major invention by man. In other words, what it means is that all future discoveries after AI takes over the world would not be dependent on humans at all, would be entirely based on machines as AI progress marches towards artificial general intelligence. Now, there's a lot of context where this is already happening. Okay, for example, the leader in chip production right now, at least those chips that are used extensively in artificial intelligence, is just one company and one product. That product is basically at this point, the most advanced version that you have is the H100 and H200 chips produced by NVIDIA. Okay, what NVIDIA is saying at this point is that it has reached a level of extensive sophistication in chip design to the point where its engineers will not be involved in future developments of the next version of their chip design. It is going to be entirely entrusted to AI because the chip design has become so complex. Actually, the CEO of NVIDIA has gone on record saying that if their engineers were to completely focus on designing the next generation of their chip, it would take them 20,000 man years in terms of the time of engineers to do that. And the company just can't afford it or doesn't have that many engineers to do it. So the only way forward seems to be AI based design. So I just wanted to give you a sense for where things are right now. It's already at a point where IJ Good's prophecy has almost come true in chip design. So I just want you to understand that. Clearly, humans are just beginning to understand the scale of changes to come as a result of artificial intelligence. It is huge. Okay, so let's kind of step back into a discussion of what are the technology catalysts. We'll review all the technologies that go into AI in a separate module, but we're only focusing on technology catalysts. Catalysts are the ones that actually facilitate the movement for technology to move forward. In other words, artificial intelligence progress. Okay, unless you have a lot of supporting mechanisms, it's not going to, artificial intelligence is not going to develop by itself. So you need all those support structures in place before it can happen. And so we'll just look at one of the three top technology catalysts here for AI development. We'll first start with hardware, okay? Computer chips evolution. So as I previously mentioned, we have gone from uh, central processor units to graphical processor units to neural processor units and intelligence processor units. So this transition, each one of them has been truly mammoth scale. So CPUs are central processing units. They primarily execute instructions in a computer program using serial processing, where they just look at the instructions in the program and do this one line by line. They execute each line. Okay, we all are familiar with that, with all the programming knowledge that we have previously learned. Graphical processing units were specially designed chips adapted for graphics and gameplay, mostly video games. Now these graphical processor units, they have parallel processing capabilities, and very interesting and serendipitous development is those chips that were designed for video games are completely appropriate for artificial intelligence computations. So you see now that GPUs are serving a dual purpose, the video games market and artificial intelligence development. On the one hand, what you see is the pace of development of artificial intelligence market has become such a huge beast. It is video games market by comparison is very small, minuscule. Okay, so you're talking about a products market evolving at a pace that was completely unexpected and completely serendipitous, and has opened up new opportunities for most businesses. NPUs are neural processing units. What these do is dedicating processing units are large, what is called as a system on a chip, designed specifically for accelerating neural network operations and AI tasks. It's meant for specific artificial intelligence tasks. So if you wish to use that specific AI application, then NPUs may be the way to go. IPUs. Now, what are IPUs? IPUs is a product that was introduced by a British company called Graphcore. Now, it also is like NPUs in some ways. It's specialized hardware accelerator designed to offload compute intensive infrastructure tasks from CPUs. So, CPUs has limited capability, serial processing, and so on. So what IPUs do, like GPUs, they offload some of the CPU load and then keep going. They can do things in parallel processing much faster. So the chips find out what kind of tasks are coming in the queue, and then assume some of these loads themselves instead of waiting for CPU to process those. These tasks include activities like packet processing, traffic shaping, virtual switching. And so all these are happening inside the computer. So all these chips are talking to each other and saying which tasks are more appropriate for each thing. The goal is to finish the task as soon as possible as a system. Okay. So they are working together harmoniously, and all this is embedded in the chip design itself. Okay. What is the second key technology catalyst? The first one was chips. The second one is the transition from what is called general purpose computing to accelerated computing. What is the big deal here? I mean, what is this transition, first of all? So, the general purpose computing is the computing that we all know, okay? Which is, most of us are familiar with a spreadsheet, we are familiar with a word processor, we are familiar with a presentation software, we are at a higher level, we are maybe familiar with advanced database software, and then so on. So, depending on your specialty, you are exposed to different types of software. All that comes under the domain of general purpose computing. What is accelerated computing? Accelerated computing is primarily devoted to solving AI problems. Okay, AI problems by definition require large amounts of data, large amounts of algorithms. So the algorithms have to process the data and make predictions, like in machine learning, or some other type of operations with different outcomes. So essentially, extremely large in terms of scale, the volume of data processed, the speed of processing is critical. And so you're looking at tasks that simply cannot be accommodated within general purpose computing because those are primarily driven mostly by CPUs. So accelerated computing will depend heavily on all these other types of chips we just described, the GPUs, the NPUs, and the IPUs. So NVIDIA started a major shift towards accelerated computing earlier in the century in order to solve hard computer problems that general purpose computing could not address. Now, what are these hard computer problems? Okay, things like predicting and managing weather change, climate change. Okay, this is a very hard problem. Okay, it's cannot be minimized just in terms of the sheer volume of data that needs to be processed, the complexity of the models that need to be estimated, and predictions. The predictions can be made, but you want those predictions to be highly accurate and mean something to the public. So accelerated computing relies on GPUs and IPUs working in conjunction with CPUs and other processors to accomplish major tasks via parallel processing. All right. So the pursuit of accelerated computing has allowed computer-generated solutions to hard problems such as modeling climate change, as I said, autonomous automobile navigation. It's incredibly complex. So Tesla has its own supercomputer that is guiding the driving of each one of its customers. Generative AI models such as ChatGPT, Microsoft's Copilot, uh, Google's Gemini, all these products require supercomputers and tremendously powerful chips and algorithms to process the data in order to make meaningful predictions. Contributions from accelerated computing become clear after considering Moore's law, which predicts that the number of transistors on a chip will double every 2 years. However, experts predict that Moore's law will no longer hold in the 2020s. Now, when Moore's law ceases to exist, when it doesn't work anymore, according to Jensen Huang, the CEO of NVIDIA, accelerated computing is going to take over, okay, and more than compensate what we are losing in terms of Moore's law not performing, okay. He estimates that the company has dramatically lowered the cost of computing by approximately 1 million times every 10 years for the past several decades. Okay, this trend is expected to continue into the future. So you can think of what the objective function is for companies such as NVIDIA. They want to lower the cost of computing to zero, so that when it actually comes to zero for the current set of problems, they go out there and tackle the next hard problem that was very difficult to solve before. So they scale up the type of problems they are solving, because of their expanded capacity to solve things now. So that's what they've been doing. The industry's goal is to lower the marginal cost of computing to zero by leveraging accelerated computing. At the same time, efficiency of computing calculations is also increasing. These two phenomena, when taken together, allow the industry to address more difficult computing problems than what we solved or what were possible to solve earlier. Okay, what is the third one? The third one is what is widely called as retrieval-based generative outcomes. We have moved from there to retrieval augmented generative outcomes that I previously described to you. Now, foundational models, which are large language models, are a form of generative AI. They are trained offline, okay, making the model agnostic to data that is created after the model was trained. So, in other words, if ChatGPT was introduced in 2022, it was trained on data previous to 2022. So if you're using ChatGPT now, unless the ChatGPT version has been changed or pre-trained on a database that is much later than 2021, you are not going to benefit from it as much. Okay, so you really need to pay attention to that. And RAG is one way to do that. Additionally, foundation models are trained on very general domains, and businesses like their large language models to function within their domain. It makes it more meaningful to them. Unfortunately, this may result in hallucinations. We are all familiar with hallucinations in ChatGPT, right? Why does hallucination happen? It's because the large language model is trained on general domains, or it was trained in a year much before the current. And so it provides lots of opportunities for the large language model to come up with inappropriate responses. Now, when you implement the retrieval augmented generative process as a supplement in terms of what prompts you ask, and steer the LLM in the right direction and make in a direction that makes sense for you, then you can use RAG to remedy that problem, because RAG can retrieve data from outside a foundation model to augment user prompts by adding the relevant retrieval data in context.
In Module 1, Lesson 3, we're going to evaluate where AI stands now on multiple dimensions. So it's very important to evaluate AI's progress from multiple perspectives. Here are the perspectives that we're going to look at here. Where does AI stand on outcomes, on various types of AI that we saw before, in terms of the magnitude of impact, in terms of the impact of ethics, on ethics, in terms of the impact of AI on control, impact of AI on speed of adoption and speed of progress, and what are some noticeable progress milestones that we can anticipate or predict. So, moving forward, let's consider the following scales dimensions or spectrums and think about where AI may fall on the spectrum at this point. With regard to AI outcome, where do you think it is between, let's say, injury on one end of the spectrum and growth on the other end of the spectrum and survival somewhere in between? Where are we here on AI? With respect to AI types, where are we right now in terms of this broad spectrum going from narrow intelligence, which we defined a little earlier, and broad AI and AGI? Where are we on this spectrum? In terms of the next spectrum, which is magnitude of improvement in business outcomes, ranging from no change to linear change to exponential change, where are we placed right now? With respect to ethical impact of artificial intelligence, ranging from negative to neutral to positive, where are we currently placed? When we say we, I'm talking about humanity. I'm talking about the current scientific climate of progress, where we are currently. The next dimension would be who will eventually be in control of AI? Is it machines or is it humans? The next dimension is speed of progress on AI. Should this be frozen? Should this be allowed to go slowly? Or can we allow AI progress to be pretty rapid? What should be, in other words, how should we formulate policy that regulates scientific progress on AI? The next dimension is where is this progress most noticeable? Is it on the generative AI component? Is it on the component that makes AI more responsible? Is it on the component that makes AI more explainable to others? The next dimension is where can AI help humans the most? Is it on repetitive and boring tasks? Is it on the longevity of the availability of AI versus the availability of humans? Is it on avoiding dangerous tasks? Is it on help with creative tasks? Now, historically, it's always been predicted that the first tasks that will be eliminated by AI are the human tasks that are currently perceived as most repetitive, most boring, and also the ones that are very dangerous. We will have a lot to talk about these specific examples on and also discuss in fairly great detail what AI's contributions have been in that area. The next dimension we'll look at is what is the relationship of AI capabilities and human capabilities? This ranges on the spectrum going from no overlap to considerable overlap to a spectrum, end of the spectrum that says AI is going to significantly augment human capabilities. So, no overlap means there is absolutely no relationship between what AI does and what humans do. And overlap means there is significant overlap in terms of what humans and AI do. And augments means that AI is significantly increasing human capability in terms of task performance. Next up is the dimension where we focus on the likely trajectory of how humans will perceive AI in future. Will humans consider AI to be adversarial? Will they be neutral? Will they be will they perceive AI as friendly? So it ranges between adversarial and friendly. Now, on each of these dimensions, if you ask a number of survey respondents, for example, a very large sample one, and every time the survey is run, we get a different set of responses because, first of all, the participants differ, and also the progress of AI defines current perceptions, and the current perceptions are constantly evolving or changing. So we have to keep those in mind. Not only are there so many dimensions to look at, but we also have to remember that these are moving targets. What is the overall assessment we have? To paraphrase I.J. Good on what he wrote in 1965, if AI continues to maintain its rate of progress, it may represent the last major invention by mankind. That is, all future discoveries could be AI or machine based, and AI progress marches towards AGI. Humans will have no role in further technology progress. Clearly, humans are just beginning to understand the scale of changes that are yet to come as a result of AGI and AI. Module 1, Lesson 4. Here we'll focus on technology catalysts for AI development. We're going to be focusing on three technology catalysts. The first one is the revolution in computer chips. It's been an evolution as well as a revolution. The evolution has moved from CPUs to GPUs to NPUs and IPUs, and now we have new categories called DPUs. And then we'll discuss the implications of this ongoing evolution and revolution in terms of the implications of transition from general purpose computing to accelerated computing. We will also discuss implications of moving from retrieval based generative outcomes to retrieval augmented generative outcomes. First, we'll focus on the evolution of different types of chips. As we all know, CPUs are an integral part of general purpose computing that we are familiar with since the inception of computers. CPUs execute instructions in a computer program using serial processing of instructions. In other words, information that is presented to the computer is processed or executed in a serial fashion, linear serial fashion. GPUs came along, and GPUs represent graphical processing units. They have become extremely popular right after 2000. They are specially designed chips adapted for graphics and gameplay. GPUs use parallel processing capabilities. Now, what is so interesting about GPUs is that GPUs were initially developed for videos and game playing, and it just happens coincidentally that their chip architecture is particularly amenable to artificial intelligence computations. So, what was originally designed to facilitate video and gameplay actually can be used or adapted very easily and very successfully for artificial intelligence applications. NPUs are neural processing units These are dedicated processing units on a larger system on a chip designed capably only for accelerating neural network operations and AI tasks. Now, NPUs are very specialized chips, and then you have other types, like you have, for example, TPUs or tensor processing units, you have DPUs or data processing units. These are rapidly emerging class of chips that enable enhanced accelerated networking. Each has a role to play along with the host CPU and create a unified balance system. Now we have to remember that CPUs have not become obsolete. As all these newer type of chips have evolved, they work together as a combined system. So you have a very integrated system that works harmoniously. Essentially, what the newer chips do is to siphon off work from the CPU to the newer type of chips like GPUs. The second aspect, which is the second technology catalyst we'll talk about, is the transition from general purpose computing to accelerated computing. This company called NVIDIA started the major shift from accelerated computing in order to solve hard computer problems that general purpose computing could not address because of its reliance on CPUs that tackle tasks best through serial processing. Serial processing, by definition, is somewhat slower because things progress in a linear fashion. When you have accelerated computing that relies on parallel processing, a lot of computational tasks can be distributed across the increased capabilities, computational capabilities of GPUs when compared to CPUs. And GPUs, additionally, they offload demanding workloads from CPUs to other processors to accomplish major tasks via parallel processing in a more efficient manner. Accelerated computing can get substantial amount of work done in less time and with less energy consumed. This makes accelerated computing more sustainable because it's less power hungry. Let's look at the implications of this transition. The pursuit of accelerated computing approach has allowed computer generated solutions to hard problems. What do I mean by hard problems? These are problems that previously computers could not solve, such as modeling climate change. We've got a number of variables, it changes over time, it involves very complex models. Similarly, autonomous automobile navigation. We previously described so many systems simultaneously at play within a self driving car. And to manage, to monitor, and to adapt across all those systems successfully and continuously requires accelerated computing. Same is true for generative AI because of all the capabilities and all the multimedia aspects that we discussed before, the multimodal aspects that we discussed before. Contributions from accelerated computing have become clear after considering Moore's law, which predicts that the number of transistors on a chip will double every 2 years. Accelerated computing significantly increases computing efficiency and capability and capacity much more than Moore's law. This is because it redefines what is computing, and the development of more sophisticated chips for AI applications has empowered even more advances in computing than what was previously possible with Moore's law. According to the CEO of NVIDIA, Accelerated computing has dramatically lowered the cost of computing by approximately 1 million times every 10 years in the past decade. So what we are seeing here is that it's actually more than past decade, because we are talking about maybe 15 years since accelerated computing has become the dominant framework for AI progress. And this trend is expected to continue or improve further into the future. Other implications of this transition are that the industry's goal to lower the marginal cost of computing to zero actually looks to be achievable in the next few years. When the cost of computing goes to zero, it means that everyone will have free access, unfettered access to limitless computing power all the time. And that is the goal of the industry at this point. At the same time, the efficiency of computing calculations is increasing. These two phenomena, bringing down the cost of computing to zero and increasing the efficiency of computing calculations, when you take them together, allow the industry to address more difficult computing problems that could not be solved earlier. The third key technology catalyst that we're going to focus on is the transition from retrieval based generative outcome to retrieval augmented generative outcome. To understand this transition, we have to really focus on or begin with what are foundation models. Foundation models are a form of generative AI. Foundation models are trained on a large core of data, and they are trained offline, making the model agnostic to data that was created after the model was trained. We have to remember that this is an important limitation of foundation models. Additionally, foundation models are trained on very general domains. They're not trained on specific domains. This makes them less effective for domain specific tasks. Let's take a couple steps back from here and understand this in the context of a specific business. A specific business wants to deploy AI so that it is useful in terms of the information that it can provide to help decision making within the context of the business and not to a very general context. For this reason, we rely on a technique called retrieval augmented generation. So, what does RAG do? If we have a large language model or a foundation model, when we find that the large language model or the foundation model has been trained on data from general domains, those models are not specifically designed to help a business with regard to addressing decision making tasks within the specific context of that business. So, what retrieval augmented generation does is retrieves data from outside a foundation model. In other words, retrieves data from within the business context and presents it to the large language model or the foundation model, so that the large language model or the foundation model can take into account the business specific data into consideration when it makes a recommendation after deploying AI processes, so that that recommendation is more contextualized, more adapted to the needs of a specific business. And that's the benefit of using RAG based responses recommendations. And that's why they are also more relevant.